Next, I would like to invite Kale from JFrog. He will take a session on achieving Kubernetes application deployments, K8s operators, and GitOps. We will learn about how Kubernetes operators automate complex tasks like deployment and scaling, while GitOps ensure transparent version control configurations like Git repositories. Welcoming Kale.
Hello, I'm audible. Feeling hungry? Yes. See, can I get speaker? Hello, hello. Feeling hungry? See, I'm the guy who is sitting between you and lunch. What do you think now? Uh, First of all, how's the Josh? Looking down. Hey man, just quickly finish this. Is it like that or how's the Josh? How's the Josh? No, we want that louder. Yes. How's the Josh? We are not going for Kargil war, but still. Okay. But इस जोश में मजा नहीं आया. Okay, how many of you knows Hindi here? Almost everyone, right? Not everyone. Okay. I don't know what this Hindi in native language, but yeah, you can feel. In today's talk, right, we'll be discussing about the Kubernetes operator and GitOps, and we'll just look into the high level things, how we can, what is exactly the operator is, what GitOps is, and how to use both of them together. My intro, I'm a software engineer at JFrog from R&D team India. I'm also senior CF incubating project Litmus Kiosk maintainer, and I'm part of all the KubeCons. I'm a committee member for KubeCon North America, Europe, China, and upcoming India as well. And apart from that, I'm also from organizing like the Kids Day also in KubeCon if you see. And when I don't do any of these things, I'm sporty guy. I'm international rated chess player. So that was my small intro. Yeah. So binaries, right? Everyone is using binaries, right? What we do? How many of you are from software, DevOps, everyone, right? Software who writes code or we are in an industry where whatever we do, let's take example, I have written Golang code, right? Or I have something Java or anything. Everything is like looked around binaries, right? Whatever we build it. So this is like where the JFrog is, where we see software as liquid, where writing the code, pushing it, it's going throughout the DevOps cycle, security and all. We provide all the stuff. And these are the latest news. If you if you travel in Bangalore, you might see a couple of places. Our holdings, our acquisitions, and couple of things are here. And we have 89% of the fortunes from top 100. We have 7,000 plus customers. And this is some of the data which I would like to show you around the JFrog's Artifactory. And yeah, this is the powering our industry. You can see like right 9 out of 10 healthcare, 10 out of 10 top finances and all. Now coming back to our talk, what do you get when you hear the Kubernetes word? I strongly believe everyone is using Kubernetes in day-to-day life, right? Or yes or no? Tell something. Okay. So what do you think? Anybody? See, one more thing. Those who are active and interacting, right? We have special swags for them. So let's interact more. So anybody wanted to say anything? Anybody? Hey man, I have to say again, how's the Josh man? Again now. Cube. Nice. Anybody else wanted to say Netis? Okay. So Kubernetes, we all know that basic things. It's a CNCF project. It's orchestration tool. But what makes different from our older way of installations, right? If you go very old, like not very old, recent only, VM based. After that, containers came. Now also there. But what exactly Kubernetes is making difference? Okay. One will say, hey man, I have Docker Compose. I will install the application using Kubernetes. and it will run my application. Why should I need the Kubernetes, right? Let's take example. I have container. We all know this in day-to-day life. We have container, but we want the better orchestration on the top of that, right? If you go for the native way, like in Linux, we have namespace, like that process namespaces, right? If you so that process namespaces, we run our processes with the resources and all, right? So in Linux, we used to run like that. Now the container concept came. In that container, this isolation and all came, and there this network namespaces inside the container. And now after having all these things, Kubernetes is playing role where it's wrapping all the things, orchestrating all the things, and on the top of that, it's having the resources. I have an application running inside the container who wants volume, storage. So Kubernetes is having persistent storage. I want if you wanted to run our application, we want a lot of things, right? We want routing, we want storage, we want our credential management. So all these configurations, right? It's Kubernetes is having resource. It's a bunch of resources working together to serve our application in better way. So these are a few things, like we just taken like couple of things here. Now I have a question. We all use these pods, deployment, services, ingress controllers, egress, route of things, right? Anyone of like you would like to explain what exactly pod is, what exactly happening behind the pod? Hey man, stacks are waiting for you. At least something. Yeah, nice. One stack is confirmed, booked. Any other? Nice. Any other thing? Okay, so how we configure the pod? We use YAMLs, right? Yeah, in YAML, what we have, we can configure the containers, bunch of containers. We can configure the volumes. It can be empty directory, ephemeral storage, or anything, whatever we want to configure. For the containers, we get lot of things, right? Probes and all, right? Labels, annotations, and multiple things we get, right? So tell me one thing, we are configuring that YAML file and we are applying that YAML file, right? kubectl apply -f pod.yaml, whatever the YAML file is, right? We are applying it, right? So once we apply, what exactly happens? Anybody would like to take on that? Any idea? Yeah, yes, ma'am. Yes. Any other? Yes. Okay, nice, nice. Anybody else? Anything else? Or okay, nice. Any other thing? Okay, let's understand the flow, and that's where our talk is going. Once we apply this pod.yaml, let's check any pod.yaml. Once we kubectl apply, we all know there is a kube config, right? .kube/config. So in that config, if you open, there will be the token, authentication, there will be the server, this host, there will be a bunch of things, right? And if you see normal curl commands to some server, right? So you will pass their bare authentication tokens, a lot of things we pass, right, in curl. So that's where these things, kubectl is the CLI. When we apply this kubectl config, right, as you said, it will authenticate. First, it will use the config. It will send that call to API, Kubernetes API server, right? And once it apply there, we all know there are Kubernetes events, right? So that's where it plays a role. So behind somewhere, some logic is written that is using this YAML and actually creating pod, right? In that pod containers, it's creating storage, it's using the volumes. If we configure the secret or anything, it is using that. So you're getting this right. Somewhere logic will be there, right? And that logic, once we apply the YAML, it's creating the pod. If we kubectl delete it, pod will go down, right? So that logic is nothing, it's a controller. And where it will run in the kubectl namespace, somewhere like some controller binaries are there, right? Inside the binary, these processes are running. One is for pod, one is for service, one is for stateful set. So once we apply deployment, what all the number of replicas and all, it will create that replica set respectively. It will create that resource and it will start performing. And whatever the responsibilities pod is having or deployment is, it will serve that, right? So that is the controller whose responsibility is to match expected versus actual. What we want in the upcoming, what we wanted, whatever we apply, that is expected. What is in the currently in the cluster, that is actual. So it will match and it will update. So that's where this flow will come. Once from kubectl applied, it will go API server. The events will come. Actually, informers are written using informers. Controller will help, and it will serve the respective responsibility. And these are the few are the just I took examples like persistent volume claim. We have volume. We have volume. Suppose we have created already. We have deployment or stateful set, and we want suppose 100 GB volume is there, and we want only 10 GB, right? We will create the persistent volume claim with the 10 GB, and we will update that in stateful set. So these are the individual resources who are performing their own responsibilities, and this is the combination, right? These are the resources. After all this, that is the after combining all, that's the orchestration. Basically, that is the orchestration which is happening around the Kubernetes. Now, small version, what is API version and kind? I think a lot of swags are still there, not yet booked. Anyone? At least kind, resource name, resource type, okay? And why we API version and kind, okay? Anybody is getting any idea why question marks are here? Okay. My again one line that how's the Josh? How's the Josh? Good. How's the Josh? One last with full energy. How's the Josh? Yes. ये क्या है? This your understanding in native language, right? Okay. So that is API version and kind, right? We'll get back to this. What is this? So let's talk about the operators now. So using operator, we can achieve this responsibility. We have seen pod deployments and a lot of other resources, right? So they are serving their own responsibilities. Secret is used for like creating, storing the credentials. Config map, we can have any file or anything. So every resource is having their own responsibility. Now, why don't we write our own responsibility, right? Okay, DevOps Day Scala. Kind is DevOps Day Scala. What is DevOps Day Scala? It's DevOps Day is based big good conference, and it is having the individual cloud native AI based SRE DevOps, right? In that also we have attendees and all, right? So why don't we write our own object, which is with responsibility to start their own respective work? Okay, I have something like let's talk about some responsibility. I want to create a resource where it will just create 10 pods and I can delete 20 pods, create 10 pods. So we can write our own responsibilities, whatever we want. It can be in CI, it can be in any part of the DevOps life cycle. It can solve our any problem. We have some problem. Let's assume that anything, anybody is having idea like, okay, I have this problem and I would like to solve. Let's think about it. So we can write our, what I'm trying to take here is we can write our own responsibility using the operator. I have some objects and I'm not able to configure few things. So I can write our own operator who's creating the deployments, creating the stateful set or pods or whatever, and it's solving that problem. It's checking the status, health checks and all, and it's after completing, it's done. It's updating status. So using the operator, we can write our own responsibilities. So what I mean to kind is we can write our own kind. Kind can be DevOps Day Scala. Kind can be pod. Kind can be Kubernetes deployment. Kind can be your name. Kind can be anything. So writing of this own kind, right? Own custom resource definition. That's where the operator comes and plays a role. And GitOps, right? In day-to-day life, where do you push your changes? GitHub. Anyone else? Anything else? Bitbucket or GitLab, anything, right? So see, developer in day-to-day life, what is using? He is using, he or she. Let's take example GitHub. So if there is a way through which whatever we do, we push the GitHub, and it will be taken into the production, right? So that's where this continuous integration, like GitOps, that's the idea, core logic of GitOps is. Any question meanwhile? How's the juice? मजा नहीं आ रहा. We want lunch now. So these are few things which we discuss about the operator. Uh, these are few frameworks which we can use: Kudo Builder, Cube Builder, or Operator framework, which will give a snippet, basic snippet of writing operator logic. In that, we just have to write our logic in that. It will generate all the manifests. It will generate a lot of Golang code. It will give us a snippet. In that snippet, we just have to write that our respective responsibility logic. And as you see, right, this in GitOps, it uses the Git repositories as a source code, and along with that, it automates process to ensure that desired and current state matches. So that is the funda basically. And to have that funda, we have a lot of tools currently. Like it's one of like Argo CD, CodeFresh is having Flux CD, Jenkins X, and few more. In this talk, we'll see Argo CD. So what Argo CD is doing that? So we discussed, right? GitOps is way through which like we will put our code in Git, and it will be synced, and wherever we wanted to launch or install, it will keep in it will keep that whole process, it will keep in sync. Whatever, if we push anything, right, if we update the pod YAML to GitHub with replica if we update the deployment, we push the deployment with the replica count 2. So inside the cluster, automatically new pod will come, 2 pods will come. And this Argo CD is a tool which is doing all these things, pushback mechanism. So this architecture wise and all, we are not getting deep down it. We are more discussing about the concept part only. So this is the way, this is the tool which is solving, which is uh, taking care of that. So see, we have GitOps. Whatever manifest we keep in GitHub, we'll see one of the examples as well in the upcoming demo. So it can be Helm chart, it can be any YAML file, or it can be anything. And here it's a deployment. So it's playing role as an intermediate. Any question? मजा नहीं आ रहा, lunch जा रहा है. Okay, let's have a small demo. I pray, hope it will work. So I will take this as an example for today's demo. So this is Potato Head. I use the Potato Head application where they have multiple services, microservices for demo. So this is a just sample repository I have for the demo. So in this sample repository, inside the manifest, I just kept one CRD YAML file. Basically in this, right, we can have different folders for secret config map. There are for Helm charts. There are different folders. We can create a .common, .kpi like that. I just kept everything inside one. And this is the GitHub repository. To save the time, I already installed Argo CD. How to install? Like in Argo CD documentation, we can easily get that. I just use that. Already installed. We can see the pods and everything is running. See, this is a Argo CD namespace. Inside that, all this controller is running. Argo CD, see again one more operator. Argo CD itself is also operator. So that everything is running, I have just created operator namespace. Okay, nothing is there. So now what we will do, we will tune our GitHub repository with the Argo CD, and we'll see this namespace. It's already logged in. Let's take demo default. We can add sync policies. We have a lot of other configurations also we can do easily. Let me take. Where it went? So we have created that. And first time demo fails, I think. Let's wait some more time. Yes, 2 minutes, 2 minutes. Okay, so we can see that we did this, it's coming up, pod is coming up. And let's see, so what I have written here, this is the manifest, inside that right config, CR manifest, potato head. So we have, what I have done, I have created a potato head as a kind, whose responsibility to deploy these pods. And let's see that deployment pods, yeah, the pods has been deployed. So that CR we can see, right? We can see here, this is the object. See, this is the object, if you describe, it has been applied. So, sounds good? How GitOps and operator is looped? Okay. Feel free to reach out to me on any social networking media, like it can be LinkedIn, GitHub, or you can create issue also on GitHub. Hey, Om, would like to connect with you. Any questions? Okay, and thank you so much. We have some goodies here from JFrog. Feel free to pick those. Thank you. I'm here only. Feel free to reach out to me. And how's the Josh? Thank you, everyone. Thank you so much.